we're kind of missing something there on the neck pickup. You should be able to see that really well there. I'm in the bridge position right now, and I'm just doing this through the guitar cable. I know that alters it a little bit, but I did a pretty thorough test in the last video. I just want to show you. Yeah, there in the neck pickup, we're getting right around 6 ohms. 6K ohms, 6,000 ohms. And in the neck position, we just don't want to get a reading. If I do both pickups, I pretty much get the same ohm reading that I get out of the bridge by itself. Let's see if we can do Henry's also for you. Let's try that again in the correct with the correct meter setting. 1.66 Henry's, which is actually relatively weak as well. And again, out of the neck pickup, I just don't get anything. It's not wanting to read out of here. The 70s guitars had a matching serial number underneath the pick guard, and there should be another one in the body cavity. So I have my soldering iron heating up. Just one last ditch effort before I disassemble and rewind this pickup is I'm going to reheat these little solder joints right here and see if that maybe fixes our problem. I don't think it will. I'll explain in just a moment what I think is happening to this pickup. But I have to try this just in the attempts to keep this all original. My meter is still set in Henry's, but it should get a reading if that did anything to help. And it's not. So my pickup wax is solid. I'm going to put this on the hot plate since I know we're going to have to pot this pickup in a minute. Very low heat on this also. Heat is probably 140 to 150 degrees. I kind of know on the dial where I'm supposed to put that to get that to 140. Continuing on, disassembly. Popped right off. This looks like plain enamel wire. I see a pretty uniform wind on that. I'm going to take a minute also and record some things like the dimensions of the pickup, things like that. It's not often that you get to see genuine stuff like this from certain time periods, so it's going to be good information to have for me in the future. I often find that when you see genuine examples and you compare it to notes found online, they usually do not match. So it's good to see the real thing here. So if I ever go to duplicate this pickup, I know how to do that. Okay, I've recorded what I want to. I think this is the correct wire. Plain enamel, 43 gauge. This looks a little newer, but I think this is the right stuff to use. So this little thin line all those guitar riffs you hear on the radio, they all come through this little thin wire as they're going around the magnet. This little thin wire has an even thinner insulation around it. As the years go by, that insulation starts to break down and this wire starts to short with itself, and that's what causes old pickups like this one to fail. Don't want to scar a magnet. I'm going to go straight in right here. If the resistance was any better, I would consider trying to save this. But with the resistance as low as it is, the break has got to be really, really deep into the coil. So I don't think it's worth trying to save it. All comes off pretty uniform. Pretty crusty stuff too. The inside still seems nice and healthy, but the outside, not so much. Could just be the wax as well, but wax should have been all the way through. In fact, this really doesn't even feel like wax. I wonder if they did some other finish. Dipped it in lacquer or dipped it in the same thing they were finishing with. I don't really know if this is wax or not. Just do the 320. Make sure that we have nowhere left for the new wire to snag as we wind this. So this is my homemade pickup winder. It's made out of pieces of another winder that the motor failed in it. Although this is just a little cheap little DC motor that's in here. I can reverse direction. I have an off in the middle, a clockwise and a counterclockwise. I can never remember which is which. I have a speed controller here. This top one counts the winds, and this bottom one is a RPM. It'll go under load. Yeah, it goes about 860 to 900 RPM. The other way goes a little faster. Yeah, you go 885, 889. 894, and it does about the same under load when I got a pickup on it. So just think in a second, the black was in the right side. The wire needs to go around the coil in this direction. It's going to be feeding in from here. So the pickup needs to spin clockwise, which would be right here. Spinning like this. So the spool goes in the floor. This guy right here is just a little contraption made out of a couple of felt pads and a clothespin. These are my little things to limit the travel left to right. Doubt you'll be able to see this, but I will try. I like to get about 3 loops through the eyelet. You can see I've got 1 through there now. I hope you can see. This stuff is really, really hard to see in person, much less on camera. To attach the pickup bobbin to the winder, I'm going to use this stuff here. I have it left over from a tile project where I did a backsplash. If anyone out there is in the printing industry, you'll know this as sticky back. It's essentially the same material, but it's a double-sided foam, kind of. That's what it is. I don't know if this is going to work. I've never used it before, but it has a little bit of thickness to it, and I have a problem I need to overcome here, is that the magnets are not flush. When I build a pickup, I typically make the magnets flush on the bottom so that I can double stick it to the winder. In this case, I'm going to have to try this with a little bit of thickness and maybe a strip on this side and a strip on this side. Almost forgot to press record, but now I'm recording. I don't do much more here than eyeball the center, both left and right and up and down. That looks pretty good to me. This little guy might end up being a problem later. Go ahead and trim him close. Probably couldn't even see that. Stuff is so thin. Okay. Now I need to work out how far I can travel. Okay, let's try all that again with the camera recording. I can't show you this while I'm doing it, but what I'm going to do is run the winder very slowly, and I'll run the wire to one extreme, and I'll set this sleeve that has just a little sleeve, has a little set screw in it. I'll be able to loosen this set screw, move the sleeve, retighten it, then I'll do the same for the other extreme to make sure that my wire is winding up inside the bobbin. Pretty happy with that. It's not 100% down there, but some of the wire will stack up off of there as it builds up, and that'll be good. So let's do this thing. We're shooting for 8,000 or just a little bit more than that, and that should give us around 7.5K resistance on this pickup with the 43 gauge wire. Alright, overshot just a little bit. That's fine. These were anywhere probably from 7,900 to 8,300. Maybe the machine wound ones were a little bit more consistent from this era, but this should be a good pickup for us. Put the last about 100 or so winds back down toward the bobbin again in preparation to send this little thin wire back through to solder to the pickup leads. Super happy with that muscle bound stuff. I think I'm going to be using that in the future. Yeah, that peels off really easily as well. Most of the time I've been doing this and have my winds fail, it's because my method of attachment failed. So it's definitely been a weak point for me. forgot about having this stuff until I ran across it the other day doing something completely different. And I was thinking, hey, I got to wind a pickup this week. How about I try that to stick the pickup on? And I think I'm going to do that from now on. And I have enough of that stuff left for, I don't know, quite a long time worth of pickups. For me, anyway. Again, this is going to be very difficult to show, but I need to get at least a few loops through here, through the eyelet. Let's get some solder on these eyelets and see what our resistance is on the pickup now. I'm going to leave the soldering iron in there for just a moment. I want it to burn through the insulation on the wire. Do the other side. .5, so a little lower than I anticipated. I don't foresee that being a problem. See what the Henry rating is. 1.73 Henrys. So this pickup should match very closely with the bridge pickup. It was 1.66 Henrys. This one is 1.72, 1.73. So the output level should be nearly the same on those two pickups, instead of that big volume drop we were getting. Alright, in we go. See a lot of air bubbles. I'm actually going to take this off the hot plate, because I don't want that direct heat on the magnets. I'll just turn the hot plate off, actually. Shouldn't need it after this point. I don't know why I'm filming so much of this. Yeah, I'm just going to cut it off here. Just takes a while. You'll slowly start to see fewer and fewer bubbles, and then I'm going to hang it out to dry. This is just a little quick and dirty rack I made one day. Scrap pieces of wood. These were insulation hangers for the insulation that's in the roof above my head right now. Just bend them up into this shape. So yeah, I'm going to give this, I don't know, about an hour to cool. Go up, eat some dinner, and probably come back down. I really want to hear this pickup, so I'm probably going to come back down and see how this thing does. Alright, I've zoomed out here so you can see the scenario. What I've done is shortened those wires just a little bit and cleaned them up. Now I'm going to tin these wires really quickly, just saturate them with brand new solder. So the white wire goes through, black wire goes through, and actually they had these the other way, through this way. Our wax has dried, by the way. Forgot to show that, but the wax has now dried on here. And there we go, that's much better. Still warm, but at least clean. If you can see that, just sort of press it. Alright. The pickup was actually a tad loose before. It wasn't like it was rock solid or anything, so I think we're okay to run it just like this. off camera, I did blow this out with a little bit of compressed air. If I had to guess, I would say all this off-color stuff in here. It comes off, but it comes off very difficult. If I had to guess, I would say all of that is polish, like off of a buffing wheel. I think that's what that is. Polishing compound. That's the word I was looking for. Yeah, let's get this thing properly installed and hear it. Temperature of the pickup will have an effect on resistance a little bit. So here in the bridge position, we're at 604. We get a reading of about halfway in between when both are active, running in parallel. Now in the neck position, we're getting about a 7.2, almost 7.19. So we are actually about where I thought we would be, between 7 and 7.5 on resistance for this pickup right here. That is, of course, adding in the cable and all that as well. So our bridge is still nice and strong like it should be. Should be. I didn't mess with it. We're getting a pretty good little Tele quack thing in the middle. The tone was down a little on that. The neck by itself. I'm real happy with that. You could do all the normal Telecaster things, tank the tone, do the jazz thing, keep the tone up, almost sounds like a Strat. All the normal Tele things that you can do out of the neck position. I think it's right. So now that the electronics are good, you got this guitar sounding right, it's going to be really good to get it playing right as well.